There we go. All right, so hello everyone, and let's talk about Bitcoin mining. All right, so our goal today is to be going through Bitcoin mining and make sure that we can define exactly what Bitcoin mining is a cryptocurrency, what mining looks like, what blockchains are, and how hash tables are used. So the first thing to start off with that would probably be the hash tables. So mining, hopefully you know at this point, mining is done with Bitcoin when your computer solves really difficult math problems to piece together a unique identity. Now that identity is then checked against a table of Bitcoin codes, and then you find out if you have a valid Bitcoin code or not. Now that table itself is what's called a hash table. And the way a hash table works is by collecting all of the valid combinations together without actually storing those combinations. Let's go and give an example first. This is very much like a username and password system. Now, hopefully I've said at least a couple of times in just passing that a good password system will never actually store your password. So let's go ahead and put together how one of those good password systems works, and then we'll relate that back to Bitcoin mining. So a hash table is used in any good password system. And how that works is, let's say we have a few users join our website. We're going to call those users J, K, L, and M. And yes, each of these usernames are just one letter long because I don't feel like writing it all out. Now let's go ahead and say each of them uses their own password to go ahead and get a good, well, at least a decent password. These are all terrible passwords, but we can pretend that they're good ones. All right, now after they put their username and password together, what happens is each of these passwords are then turned into a unique set of what are called hash codes. These hash codes are based on a hash function, which takes each of those and turns them into an index, a number. So let's say that these are the four hash code values that we get from these four passwords. Well, since Jay's password mapped him to the letter 5, we would look at our table, go 1, 2, 3, 4, 5, and put Jay right in there. Now, this is actually what we would see. We would see that their username was placed at that index on the table, and that's it. Okay, we go to index 15, L will go to index 6, M to index 7. Let's go and put another person in there, N, who said yes as their password, and that mapped to 18. All right, cool. So hopefully it makes sense that these are correct indices based on what hash code we get based on the password. Now, hash function can work in many different ways. You might be thinking of some ideas already. But basically, the hash function turns a password into an index. That username is put at that index in the table. The password is never actually stored. When Jay later tries to sign in, if he uses the wrong password, like let's say he tries to use hi, which we already know leads to 15, it's going to look at index 15 right here and say, okay, is Jay right there? And the answer is, of course, going to be no. Jay is not present at that location. So at that point, it will say, sorry, wrong username or password. Now, it's not sure if Jay just meant to type K and thus, had the right password but the wrong username. It's also not sure if this isn't Jay and it's someone else trying to guess his password. It doesn't know. So it will always say either your username or your password is incorrect because it doesn't know. which one was actually wrong. Now, conversely, if J were to put in hello again, that would map to index 5. It would look at index 5 and see, oh, yep, that's him. Let him on in. So that's how a hash function works in usernames and passwords. This idea is also extended into the cryptocurrency world. So hopefully you get how this works. It works in hash tables in this way. That really long ID is like a password. It maps to a certain number. So then when we get that, so when we try that ID, what'll happen is we track it against our hash table. It is turned into a code by the function. The code then checks that specific one and sees if it's valid or not. Notice, the actual codes for Bitcoin are not stored here. There is no library that just has all the valid codes. Instead, it has the valid locations of codes. So that means, or the locations that the codes would map to, not necessarily where those codes are stored somewhere else, but just simply where they would map to. So obviously the 71 here is incorrect. That would not be a valid code. We maybe try another ID, and this time it maps to, that's under mine. This time, let's say it maps to 74. It checks here. Is that valid? Yes, it is. That's a valid Bitcoin. Congratulations, you just made $7,000. So yeah, that's how a hash table functions, and that's how a hash table functions with Bitcoin. So with that said, hopefully you get that how hash tables are involved in the Bitcoin process. Okay, so let's go ahead on. Let's address this topic of artificial scarcity. Artificial scarcity. Artificial scarcity is the fact that even though, theoretically, there are so many more IDs possible, because remember, this is a gigantic ID. That means every single character in that ID could be anything from 0 through 9, from A through Z, through capital A through Z, through all the special characters, all that stuff. Could be all those. So there are really a lot of options, right? There are tons of options for it. However, when they were made, it was decided that there would only be 21 million unique Bitcoin IDs. True, valid Bitcoin IDs. Only 21 million. So that means that there are, that means that every time that someone thinks they find one, they have to check it, and if it's not one of these 21 million, then it's not a valid code. So far, we have discovered, through mining, 12 million of them, meaning there are 9 million left. From 2009 to 2017, the years that Bitcoin has existed, we have found 12 million valid Bitcoin IDs. There are still 9 million left. Now, there's a reason for the scarcity. Around the same time that Bitcoin was made and getting popular, another thing called Dogecoin was made. Now, perhaps you remember the meme, the Doge, who would look at things and say stuff like, oh, such coin, much value. That's actually what's written on the Dogecoin itself. Dogecoin is a joke currency. It was released with unlimited circulation, meaning there is no limit on it, whereas Bitcoin had a limit of 21 million. Dogecoin was designed without any limit. So, that being said, Dogecoin started off at about, I think around a few dollars, maybe about $3 or something. I'm trying my best to remember. But it started around there. Over the next couple of weeks, it grew to being a few $100s, before later balancing out at 1 over $3.6 thousand. And then today it's around 1 over 831. So as you can see, even if this is kind of an increase from 3600th of a cent of a dollar to being 830th of a dollar, it still is extremely low. That is because there's no scarcity involved in it. We could always just keep making more and more Dogecoins. But the more Dogecoins that get made, the lower the whole currency is. Also, with that lack of a limit, no one really wants to accept Dogecoin. I'm going to switch over to a website containing on it a big list. Sorry, that's the wrong website. This one. So this is a gigantic list. All of these sites accept Bitcoin as payment. That's a lot. However, the list of ones that accept Dogecoin is well, yeah. Yeah, it's not very high. So if your if your currency has no limit on it, has no real scarcity attached to it, no one's going to use it. That also helps drop the value big time. For Bitcoin, it has a lot of people using it, including Microsoft, Subway, Newegg, Steam. A lot of places are accepting Bitcoin. That combined with the limited circulation for that artificial scarcity has allowed Bitcoin to remain a valuable currency that even when it drops down significantly, perhaps dropping back down to $6,000, or maybe even it could drop back down to $729 again, even if it did that, it wouldn't drop too much more. It wouldn't go like Dogecoin to become less than $1, even less than a cent. This is like 0.15 cents, I think. Instead, it has a limit on how far down it can drop. So with that limit being enforced, Bitcoin is allowed to be a real stable currency. Now, I say stable only because it will never become this. It is not stable in that it will stay the same. All currencies fluctuate in value over time, and that's okay. Every nation's currency will fluctuate. That's all fine. All right, let's see. So hopefully that makes sense. Hopefully you get that, how Bitcoin relies on scarcity. Now, let's just go ahead and address this idea of blockchains. A blockchain is where each of the blocks are chained together to form an identity. You see, every time someone joins the Bitcoin network, that means that there is another block added somewhere to someone's computer. Sorry, whenever you join it, let me go and rephrase that. Whenever you join the Bitcoin network, blocks of data are put onto your computer. Now, those blocks can be chained together, and when they're chained together, they form one ID, one identity. That identity might be valid, might not be valid. You have to put the blocks into the correct order across all these computers on the Bitcoin network in order to find blocks that actually work. There are a lot of them. There are a lot of those things that actually work. For instance, here's some blockchains. Block 11 found on January 9th of 2009 contained this gigantic code. The next one contained this code. Next one after that contained this code. These are all the ones that were found in the order that they were found. So, to be clear, blocks are put together into a blockchain. That blockchain can be tested as a valid ID. If it is valid, then you have an actual Bitcoin. That is basically what a blockchain is. A blockchain is a collection of blocks of data that are used to form one unique identity. That's really about it. All right, thanks for watching.